Welcome to Thales DMS in France. I am delighted to present our project today. So what needs do we meet with ScanOcean? First need, last year many armed forces in the world asked for a solution of underwater drone that is still not provided. No one has yet been able to offer a completely autonomous underwater drone for acoustic intelligence missions. The second need is anti-submarine detection. Thales DMS already produces underwater drones, including for mine warfare, but not for anti-submarine detection.
Our goal for the Thales Tech Challenge was to create an object that can detect enemy submarines without threatening human lives. In order to be efficient and marketable, we designed a module that can upgrade a Thales drone. We particularly wrote algorithms and added few hardware components. Reliable, low cost and stealth, ScanOcean will be the next generation of submarines tracker.
Our long-term goal is to design a drone able to track submarines by making the distinction between inoffensive sound sources like dolphins and submarines. To prove our idea, we created a prototype and designed an experience using a surface drone instead of a submarine drone, knowing that we could easily adapt our 2D detection system to a 3D environment. In our experiment, the drone had to follow a targeted boat playing the role of a submarine and to ignore inoffensive sound sources displaced in the area.
After the Thales Tech Challenge France, we managed to have a partnership between Thales and Centrale Supélec to help us work at Thales Underwater Systems in Brest. We worked with Jean-Philippe Brunet, researcher and engineer at Thales Underwater Systems, and his intern Julien. Facing the COVID crisis, we continued working especially on Teams and Skype. We were working together in Brest at Thales Underwater Systems when each of us came back home to confine ourselves. This year, our project was also presented to high representatives of the French Direction Générale de l'Armement, who showed good satisfaction about our project.
The autonomous navigation system of our drone relies on behavior trees and on our ROS, which means Robot Operating System, with MQTT protocol. To control the drone, we designed with Thales members a human-machine interface showing the position, the speed, the head and the mission followed by the drone, with which we could easily give it orders.
Now, let's talk about acoustics. How do we detect, identify and know the position of the noisemakers, the targets surrounding the drone? The passive acoustic signal is acquired through a network of hydrophones. Then the targets are detected and spatially separated using a conventional signal processing technique, including Hose transform and the waterfall method. The targets are finally classified using artificial intelligence. So let's focus on artificial intelligence, the very added value of our project.
For each sound emitter on the track of the drone, we get a time signal and compute a spectrogram given by the Mel frequency substrate coefficients, or MFCC, a technique close to human hearing which gives the characteristic pattern of the sound. Combining recognition of both MFCC spectrogram image and time signal sequence, we can distinguish tiny differences, such as the one between a liner and a submarine.
Starting from this work, we would like to develop further our project with Thales experts. We are already digging further the AI part with Centrale Supélec. Thus, we are thinking about transferring the intellectual property rights of our achieved work to our partner companies. Hopefully, ScanOcean will be the next generation of submarines tracker.